In this video, we're going to go through a trigonometry test review, and we're going to go through 25 questions. We're going to cover topics such as Pythagorean Theorem, the converse of the Pythagorean Theorem. We're going to work with the sine, cosine, and tangent ratios. We're going to work with inverse sine, cosine, and tangent ratios to solve for angles. We're going to talk about the geometric mean, the law of sines, and the law of cosines. This is a trig review mainly aimed at like geometry level students. I've got another one that's more aimed at pre-calculus students, so you can check that out on my Math Tutoring YouTube channel. But let's dive into this video. You might want to try and pause the video and do some of these problems on your own, and we'll go through them together. So let's get started. What would you do for this first example here? We're trying to solve for this missing side length, and you can see it's a right triangle. So when you have a right triangle and you have two of the three sides, that's when you want to use the famous Pythagorean theorem, right? So that's the a squared plus b squared is equal to c squared. Just remember, a and b are the sides that make up the right angle. Those are the legs. And the one across from the right angle, that's the longest side. That's our hypotenuse. That's the side c. So in this case, we're going to say 6 squared plus 10 squared is equal to x squared. Okay, 6 squared we know is 6 times 6, that's 36. 10 squared is 10 times 10, that's 100. So now we have x squared is equal to 136. We're going to take the square root of both sides to get that x by itself. And then now we're going to want to try to simplify this square root. Some teachers will let you write it as a decimal to the nearest tenth or the nearest hundredths place. But let's see if we can write this in the simplified radical form. So what you want to do is you want to pull out perfect squares. One way to do this is to do a prime factorization tree. For example, I can see that this is even, so I can divide this by 2. So 2 times 68 is 136. 68 is 2 times 34. And 34 is 2 times 17. Now, when you take the square root, you're looking for groups of 2 of the same number. That's like a perfect square. So this is going to be 2 with 17 times 2 left over. So this is going to be 2 square root of 34. And that's this missing side length right here. Okay, let's go to number 2 now. So for number 2, same idea. We've got a right triangle. However, we're looking for the missing side or the missing leg. We've got the hypotenuse. That's the longest side. That's side C. So again, using that famous Pythagorean theorem, we've got 4 squared plus x squared is equal to 8 squared. 4 squared is 4 times 4, 16. 8 squared is 8 times 8. If we subtract 16 from both sides, we get x squared equals 48. Now we're just going to take the square root to get x by itself. And again, we're going to try to simplify this square root. 48 I know is 16 times 3. The square root of 16 is 4. And we have the square root of 3 left over. There's not any perfect squares we can pull out of 3. So that's as far as we can go. So that's another way to do it, is to look for perfect squares. The other way is to make like a prime factorization tree and look for 2 of the same number. Okay, for number 3 now, we're asked, is this a right triangle, an acute triangle, or an obtuse triangle? Now the formulas that you want to remember are this one right here. Is c squared greater than a squared plus b squared? If it is, it's obtuse. If it's equal to, it's right. If it's less than, it's acute. So how do we know which is the side C, A, and B? Well, C is the longest side. A and B are the 2 other sides. A is usually the shortest, and B is the medium, and C is the longest. So let's see what this looks like. We've got 14 squared, question mark, 4 squared plus 12 squared. Okay, 4 squared is 16, 12 squared is 144. 14 squared is 14 times 14, that's 196. This comes out to 60. But you can see that 196 is greater than 160, which means that this is actually an obtuse triangle. Now, one thing you want to be careful when you're doing these problems is sometimes they try to trick you, and there might not even be any triangle possible. So if these 2 sides are not greater than the third largest side, it's not going to be a triangle. So basically, that's called the triangle inequality theorem. Any 2 sides have to add up to more than the third side. So like a plus c has to be greater than b, a plus b is greater than c, b plus c has to be greater than a. But it's usually, if it's going to fail, it's the 2 smaller sides that are not going to add up to greater than that largest or longest side. Let me erase the whiteboard. Let's do the next group of problems. Let's talk about special right triangles. So remember the 45, 45, 90 and the 30, 60, 90 special right triangles? That's what these next group of problems are aimed at. So when you've got a 45, 45, 90, see, they're giving us the leg here. We want to find this other leg, and then we want to find the hypotenuse. So what you want to remember is that the two legs are going to be congruent to each other. So if this is 8, this one is also going to be 8. But to go from the leg to the hypotenuse, you have to multiply by the square root of 2. So this is hypotenuse is going to be 8 square root of 2. So you want to remember that ratio. It's like x, and x root 2. So for number 5 now, they're giving us the hypotenuse. You can see it's a 45, 45, 90 if these two acute angles are congruent and you've got that right triangle. But to go from the hypotenuse to the leg, what do? You have to divide by the square root of 2. Now you don't want that radical in the denominator, so you're going to multiply the top and bottom by square root of 2. That's going to give you 12 square root of 2 over square root of 4, which is 2. The 12 and the 2 reduce, so this just becomes 6 square root of 2. Now remember, the two legs are the same, so this is also going to be 6 square root of 2. Okay, moving on to the 30, 60, 90 triangle. Remember the ratios. I'll show you right here. So basically the one across from the 30-degree angle, that's the short leg. We call that sometimes like S. And then the one across from the 60, we call that one like S square root of 3. And the one across from the 90, that's like 2 times S. So that's something that you can remember there. But if they're giving us side S, to get to S root 3, the longer leg, all we have to do is multiply by the square root of 3. Square root of 3 is about 1.7, so it's about, about 1.7 times longer. To go from the short leg to the hypotenuse, see from S to 2S, you're just doubling, so this hypotenuse is going to be 8. So it's pretty easy if they give you the short leg, you just double it to get the hypotenuse or multiply by square root of 3 to get the longer leg. For this one though, the 30, 60, 90, they're giving us the hypotenuse. So remember, that's like the 2S side. The one across from the 30, that's the short leg, that's like the S side. To go from 2S to 1S, we have to divide by 2, right? So 10 divided by 2 is 5. And to go from the short leg to the longer leg, you just multiply by the square root of 3. Now, if any of these topics you want more practice with, I've got on my Mario's Math Tutoring YouTube channel videos about special right triangles, 30, 60, 90, 45, 45, 90, or if you want to learn more about the Pythagorean Theorem or the converse of the Pythagorean Theorem. So let's look at number 8. So for this one, we've got a 30, 60, 90. Here they're giving us the longer leg. So again, a lot of students like this technique where you write S root 3, this is the 2S side, and this is the S side, or the short side. So one across from the 30 is S, one across from the 60 is S root 3, across from the 90, that's the hypotenuse 2S. So that kind of helps guide us. How do I get from S root 3 to S? Well, I have to divide by square root of 3 to get the S by itself. So that's what I'm going to do. I'm going to take 9 divided by the square root of 3. Oops, 9 divided by the square root of 3. But we don't want that square root of 3 in the denominator. We have to rationalize. So we have to multiply the top and bottom by square root of 3. So that gives us 9 square root of 3 over square root of 9, which is 3. 3 goes in here once, 3 goes in here 3 times. So it just comes out to 3 square root of 3. But to go from the short leg to the hypotenuse, we're multiplying by 2. So this is going to be 6 times the square root of 3. Don't make the mistake of saying 6 square root of 6 or 3 square root of 6. You're just multiplying this integer times 2. So 3 times 2, 6 square root of 3. Okay, now moving on to the geometric mean. If we want to find the geometric mean of two numbers, you can use this formula. It's x equals the square root of a times b. Or some teachers will set it up like this. They'll say these are the means and these are the extremes. So if I put 8 and 12 here, x is here. If I cross multiply, I get x squared is equal to 96. And then if I take the square root, that's 16 times 6. Square root of 16 is 4. So 4 root 6 would be our geometric mean. Again, this is kind of like a shortcut. You just multiply the two numbers together and take the square root. But some people like to set it up as a proportion. This is, again, called the means extremes property. Let me erase the whiteboard. Let's do the next group of problems. Look at number 10 now. So number 10, we've got this right triangle. And we're dropping an altitude that's perpendicular to the base here. And what happens is you end up getting 3 triangles that are similar to one another. You have the small triangle, the medium, and the overall triangle. Now there's 2 theorems that you might need to review on if you haven't learned this, but the altitude is the geometric mean of the 2 parts of the hypotenuse that it splits it up into. So remember we were talking about geometric mean just a minute ago. This is the mean here, and these are the 2 parts of the hypotenuse that it's splitting up into, so 3 and 9. So if I cross multiply, I get 27 equals x squared. Take the square root of both sides. And 27 is 9 times 3, so this just comes out to 3 root 3. So just remember the altitude is the geometric mean of the two parts of the hypotenuse that it splits it up into. So pretty neat formula. Now for number 11, there's a leg theorem, leg geometric mean theorem, and the leg is the geometric mean of the whole hypotenuse, so that's 4 plus 5, so that's 9, the whole hypotenuse, and the part of the hypotenuse that's adjacent to that leg. So now if we cross multiply, we get x squared is equal to 36. Take the square root of both sides, x is equal to 6. So again, the leg is the geometric mean of the entire hypotenuse and the part of the hypotenuse closest to that leg. So for number 12 now, we're solving for this leg here. So same leg geometric mean theorem. The leg is the geometric mean of the entire hypotenuse, which I didn't write down here. Let me write it down now. It's 12, which means that this piece here must be 12 minus 3, 9. So again, the leg is the geometric mean of the whole hypotenuse and the part of the hypotenuse that's adjacent or closest to that leg. So some people make the mistake of saying, 3 times 9. That's for the altitude. The altitude is the geometric mean of the two parts of the hypotenuse that splits it up into, but the leg is the geometric mean of the entire hypotenuse and the part of the hypotenuse that's closest to that leg. So now just cross multiplying, we get x squared equals 108. Take the square root of both sides. I know 108 is 36 times 3, and I know the square root of 36 is 6, so this would be 6 square root of 3. And for number 13 now, moving on to the sine, cosine, and tangent ratios, you probably remember from your classes in geometry here, the SOH CAH TOA acronym, right? SOH CAH TOA. Sine is the ratio of the opposite side divided by the hypotenuse, cosine is the ratio of the adjacent over the hypotenuse, and tangent is the ratio of the opposite over the adjacent. So SOH CAH TOA. Now here they're giving us 2 of the 3 sides. We have to solve for this third side. We can do that by using the Pythagorean Theorem, a squared plus b squared equals c squared. Or if you recognize this as a Pythagorean triple, 8, 15, 17. So you might want to refresh on your Pythagorean triples. 3, 4, 5 is a common one, or multiples of that. 5, 12, 13 is a common one, or multiples. 7, 24, 25. And this one here, 8, 15, 17. Those come up a lot. So if I want to find the sine of angle A, remember we stand over here at angle A. Sine is the ratio of the opposite side, which is 15, over the hypotenuse. That's always going to be the one across from the right angle, 17. If I want the cosine of angle A, I want the adjacent side divided by the hypotenuse. Adjacent's next to, okay, so 8 divided by the hypotenuse, 17. Now sometimes people say, Mario, isn't 17 adjacent to this angle? Well, this one's always going to be the hypotenuse, the one across from the right angle. So adjacent is going to be the other one that's next to that angle. And then the tangent is going to be the ratio of the opposite side divided by the adjacent. So opposite, that's across, that's 15, divided by adjacent, that's 8. Okay, now if we switch gears here and move over here to angle B, sine of angle B would be opposite over hypotenuse, that's 8/17. Cosine of B is adjacent over hypotenuse, that's 15 over 17. And tangent is going to be opposite over adjacent, so that's 8 over 15. So again, it depends on what angle that you're working with. You're not going to be working with the right angle, one of these 2 acute angles, and you just have to remember the SOH CAH TOA acronym to remember the ratio of the sides. So let me erase the whiteboard. Let's do some more examples. Okay, let's see if we can do this next group of problems. Number 14, we're given this angle 22 degrees. We've got a right triangle, and we know this side opposite, and we're looking for the side adjacent. So using that SOH CAH TOA acronym, this is the ratio of the opposite and adjacent. That's the tangent. So we're going to say the tangent of our angle, tangent of 22 degrees, equals the ratio of the opposite over the adjacent. Now what we can do is we can cross multiply. 4 times 1 is 4. This is x times the tangent of 22. Divide both sides by tan of 22 to get x by itself. And we'll go to the calculator. Now this part, you're going to have to kind of get used to your calculator. Make sure you're in degree mode, okay, because we're working with degrees. And we're going to do 4 divided by the tangent of 22. So that's how mine works. Now, some calculators, you might have to put the angle in first and then press the tangent button. But in this case, I'm getting an angle, a side of 9.9. So that's this missing side here, 9.9. Okay, number 15, same idea. We've got a right triangle, and it looks like now we've got this angle 53 degrees. We're looking for the side opposite and we have the hypotenuse. So remember from that SOH CAH TOA acronym, opposite and hypotenuse, that's the sine ratio. So we have the sine of our angle, 53, equals the ratio of the opposite x over the hypotenuse, 14. If we multiply both sides by 14 to get x by itself, let's see what 14 times the sine of 53 is. That's about 11.2 if I round to the nearest tenth. For number 16, we've got the adjacent and the hypotenuse. So that's the cosine. So we're going to say the cosine of 15 degrees equals the adjacent over the hypotenuse. Remember cosine, CAH, A over H, the second letter over the third, adjacent over hypotenuse. We can multiply both sides by x to get rid of this fraction here, but then we're going to have to divide both sides by cosine of 15 to get the x by itself. So what's 8 divided by cosine of 15? I'm getting about 8.3 if I round to the nearest tenth. For 17 now, it's a little bit different, 17, 18, and 19, because we're solving for the missing angle. So when you're finding the missing angle, you're going to have to use the sine inverse, the cosine inverse, or the tangent inverse. You might have to press the second key on your calculator to access those. So here we've got the opposite and the hypotenuse. That's the sine ratio. So I'm going to say x equals the sine inverse of opposite over hypotenuse. So sine inverse of opposite over hypotenuse, I'm getting about 20.9 degrees. That's this angle right here. For number 18, we've got opposite and adjacent. That's tangent. So x is equal to the tangent inverse of opposite over adjacent. And let's see what that comes out to. 11 divided by 3. About 74.7 degrees. And for number 19, let's see, we've got adjacent and hypotenuse. That's the cosine. So the x is going to equal the cosine inverse of adjacent over hypotenuse. If you need help with any of these topics, I've got more videos talking about the inverse trig functions, inverse sine, inverse cosine, inverse tangent. So let's see what this comes out to. I'm getting 54.3 degrees. Okay, let me erase the whiteboard. Let's do the next group of problems. Let's do a couple of word problems or story problems. So we've got a 10-foot ladder is leaning up against a building with a 70-degree angle of elevation. How high up does it reach? Okay, so first thing you want to do is you want to draw a diagram. And here we're talking about angle of elevation. So this is an important concept in geometry. So elevation, you're looking up from the horizontal like that. So say here's the building. Okay, here's the ladder. Okay, and then the angle of elevation is this guy right here. So that's 70 degrees. And we want to find out this height right here, how high it reaches up the building, and we know it's a 10-foot ladder. So we're asking ourselves what trig function ties together this angle, the opposite side, and the hypotenuse. That's the sine ratio. So that would be the sine of 70 equals opposite over hypotenuse. Multiply both sides by 10 to get that height by itself. And let's go to our calculator. Let's see, 10 sine 70. I'm getting about 9.4 feet. 9.4 feet. Okay, for number 21 now, the angle of depression from a hawk perched upon the top of a tree to a squirrel on the ground is 35 degrees. Find the distance of the squirrel from the base of the tree. Now, angle of depression, you're looking down from the horizontal. Okay, so let's just say that this is the tree here. Okay, hawk's up here, squirrel's down here. We're looking for the distance from the base of the tree, so let's call that x. There's the line of sight. Now, the angle of depression, sometimes students mistakenly use this angle because they see it's inside of the triangle. But what you want to do is draw like a horizontal line like that, and you're going down from the horizontal. That's 35 degrees. And let's see, we don't know how tall the tree is, so we need a little bit more information here. So let's just say that this tree is a 100-foot tall tree, 100 feet. Okay, so now again, we're going to assume this tree is vertical, straight up, it's not leaning. We're also going to notice that the angle of depression and the angle of elevation are congruent. These are what are referred to as alternate interior angles, okay? One's on the right side of the transversal, one's on the left, and they're in between the parallel lines. So what trig function ties together this angle, this side, and this side? Well, that's opposite and adjacent, that's the tangent. So we're going to say the tangent of 35 degrees equals opposite 100 over adjacent x. We're going to cross multiply, so x times tangent of 35 equals 100, and then I'm going to divide both sides by tan of 35 to get x by itself. And let's see what that comes out to. So 100 divided by the tangent of 35, 142.8 feet is this horizontal distance. Let me erase the whiteboard. Let's do the next few problems. Before we dive into these next two examples involving the law of sines and then after that the law of cosines, if you're enjoying this review and you want to go deeper in geometry, I've got a geometry course for sale. You can check that out in the video description below. Or if you join as a channel member at the additional videos level, you can have access to my full geometry course here on YouTube, as well as other videos as well on that additional videos members level. So check that out if you want to go deeper with me in geometry. But let's go ahead and look at number 22 now. So what you want to do is you want to look at the fact that this is not a right triangle, so we can't use the regular sine, cosine, and tangent. But what we do have is we have the angle on the side opposite and the angle on the side opposite. So we can think of those as a pair. There's only one unknown. We can make a proportion. We can solve for x using the law of sines. And the way the law of sines works is you say the sine of the angle over its side opposite is equal to the sine of one of the other angles in that same triangle over its side opposite. And that's how you make a proportion. As long as there's only one unknown, you can solve. So what I'm going to do is I'm going to cross multiply. So that's 12 times the sine of 17 equals x times the sine of 100. I want to get x by itself, so I'm going to divide both sides by sine of 100. And we're going to go to the calculator. Make sure your calculator's in degrees. Let's see what we get here. We've got 12 sine 17 divided by sine of 100. I'm getting 3.56, or I'll just round to about 3.6. That's this missing side right here. For 23, same idea. You've got this angle in the side opposite, angle in the side opposite. We can go ahead and use our law of sines. We're going to say sine of x over its side opposite 15 is equal to sine of 48 degrees over its side opposite 12. I'm going to multiply both sides by 15 to get sine of x by itself. And let me just see what this comes out to just roughly. So 15 sine of 48 divided by 12. Okay, so it's about 0.929. Okay, so that's sine of x. But to solve for the angle, we're going to have to do the sine inverse. So x is equal to the sine inverse of 0.929. I'm just going to use the previous answer key on my calculator here to get a little bit more accuracy. And that comes out to about 68.3 degrees. So I'll just say approximately 68.3 degrees. Let me erase the whiteboard. Let's do the last two examples using the law of cosines. Okay, see if you can do these last two examples if you're familiar with the law of cosines. Here we're solving for the missing side. Here we're solving for the missing angle. Now remember, there's different ways to write the formula for the law of cosines. There's the c squared equals a squared plus b squared minus 2ab cosine angle c, or sometimes you'll see it as b squared equals a squared plus c squared minus 2ac cosine angle b. There's different ways to write it, but essentially, if you're solving for the side across from the angle, by the way, when you use the law of cosines, is if they're only giving you side, 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 like three sides but nothing else, or if they're giving you side, angle, side, just the angle in between two sides that you know the lengths of, and you're solving for that side opposite, that's when you have to use the law of cosines. The law of sines won't work. You'll have too many unknowns, too many variables. So, but here what I'm going to do is I'm going to think of this as my angle C. I'm going to think of this as my side C. I'm going to think of these two sides that make up angle C as side A and B. So what we're going to do is we're going to say x squared is equal to 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of the included angle, 80 degrees. Now I want to solve for x. I'm going to take the square root of both sides, and that's going to give us our missing side length here. So let's go ahead and see what that comes out to. We got the square root of 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of 80 degrees. Okay, that's 9.1. We'll just say approximately 9.1. Okay, for number 25 now, same idea. We're given three sides. We have to use the law of cosines, but we're solving for the missing angle. So I'm going to call this angle C, and we're going to call this side C. We can call this side A and this side B. Okay. So I'm going to write the formula down. We've got c squared equals a squared plus b squared, just like Pythagorean Theorem, minus 2ab cosine angle c. We know side c is 5, a is 7, b is 8, and we don't know the angle, cosine of x. So what we have to do is we have to get this cosine x by itself on one side of the equation, and then take the cosine inverse to solve for that angle. So let's do this step by step here. So 5 squared is 25. 49 plus 64 is 113. Let's see, 7 times 8 is 56, times 2 is 112. Now here's the mistake that students sometimes make, and I don't want you to make this. You don't want to combine these and say this is 1. Because see, this is all multiplied together. It's like one group. So we have to subtract the 113 from both sides. That's negative 88 equals negative 112 cosine angle x. Let's divide both sides by negative 112. Let's see what that comes out to. Okay, so it's about 0.786 equals cosine of x. But to solve for the angle, we're going to take the cosine inverse of 0.786, and that's going to give us our angle. So let's do that. I'm going to use the previous answer key here. So it's about 38.2 degrees. So great job if you were able to follow these examples in this review. If you want more practice with geometry, I'll put a video geometry final exam review right there. So you can check that out if you want to learn more about geometry. Otherwise, good luck on your exam, and I'll see you in my next video.